For example, carbon monoxide and hydrogen react to give different products in presence of different catalysts. Shape-selective catalysis by zeolites. The catalytic reaction that depends upon the pore structure of the catalyst and the size of the reactant and product molecules is called shape-selective catalysis. Zeolites are good shape-selective catalysts because of their honeycomb-like structures. They are microporous aluminosilicates with three-dimensional network of silicates in which some silicon atoms are replaced by aluminium atoms. The reactions taking place in zeolites depend upon the size and shape of reactant and product molecules as well as upon the pores and cavities of the zeolites. Zeolites are used as catalysts in petrochemical industries for cracking of hydrocarbons and isomerization. Enzyme catalysis. Enzymes are complex nitrogenous organic compounds which are produced in living cells of plants and animals. They are also known as biochemical catalysts because of their importance in biochemical processes. Almost all enzymes are complex protein molecules with high molecular mass. Enzymes are produced by living cells. A typical cell, on an average, contains about 3,000 different kinds of enzymes, each enzyme catalyzing a particular reaction. For example, conversion of milk into curd by lactobacilli enzyme present in curd. Characteristics of enzyme catalysis. Enzymes form a colloidal solution in water and hence they are very active catalysts. Like inorganic catalysts, they cannot disturb the final state of equilibrium of a reversible reaction. They are highly specific in nature. One catalyst cannot catalyze more than one reaction. They are highly specific to temperature. The optimum temperature of their activity is 35 degrees Celsius to 40 degrees Celsius. They are deactivated at 70 degrees Celsius. A small quantity of enzyme catalyst is sufficient for a large change. They are destroyed by ultraviolet rays. Their efficiency is decreased in presence of electrolytes. Mechanism of enzyme catalysis. The enzymes are highly specific in their action. The specificity of an enzyme is due to presence of some specific sites called active sites. These active sites are associated with the presence of some functional groups which undergo some weak interactions with the substrate molecule. The shape of active site on a given enzyme is such that only a specific substrate can bind with it. This specific binding of the active site with the substrate results in the formation of enzyme-substrate complex. In this complex, the substrate molecules are held in appropriate steric orientation to facilitate the reaction. After achieving proper orientation, substrate molecules react to form the products. As product molecules do not have affinity for the enzyme surface, they immediately leave the surface so that fresh substrate molecules bind with the active site. Colloids. A colloid is a heterogeneous system in which one substance is dispersed as very fine particle having diameters in the range of 1 to 100 nanometer in a continuous medium of another substance. For example, milk, shaving lather, jelly, and paint. A colloidal solution is heterogeneous in nature and always consists of at least two phases, the disperse phase and the dispersion medium. Disperse phase. It is the component present in small proportion and consists of particles of colloidal dimensions. Dispersion medium. The medium in which colloidal particles are dispersed is called dispersion medium. Classification based on physical state of colloids. Dispersed phase and dispersion medium can be solid, liquid, or gas. Therefore, 8 types of colloidal system are possible depending upon the physical state of the dispersed phase and the dispersion medium. Rock salt is an example of solid sol. Paint is an example of sol. Smoke is an example of aerosol. Cheese is an example of gels. Milk is an example of emulsion. Fog is an example of liquid aerosol. Rubber is an example of solid foam. Soap lather is an example of foam. Classification based on physical state of colloids. On the basis of nature of interaction between dispersed phase and the dispersion medium, colloids are divided into two categories. Lyophilic colloids. Particles of dispersed phase have great affinity for the dispersion medium. They are self-stabilized because of strong attractive forces operating between the suspended particles and the dispersion medium. They are reversible in nature. They are also known as intrinsic colloids. For example, gums, starch, gelatin, and albumin. Lyophobic colloids. Particles of dispersed phase have no affinity for dispersion medium. Rather, they hate dispersion medium. They are not easily prepared and need stabilizing agents for their preservation. They are irreversible. They are also called extrinsic colloids. For example, sols of gold, silver, and ferric hydroxide. Classification based on physical state of colloids. On the basis of nature of the particles of dispersed phase, colloids are divided into three categories. Multimolecular colloids. In this type of colloids, colloidal particles are aggregates of atoms or small molecules with molecular size less than 1 nanometer. These molecules in the aggregate are held by van der Waals forces. For example, a gold sol consists of particles of various sizes, which are clusters of several gold atoms. Macromolecular colloids. In this type of colloids, colloidal particles are themselves large molecules having colloidal dimensions. They have very high molecular masses, varying from thousands to millions. For example, proteins, cellulose, nylon, and plastic. Associated colloids. This type of colloids behave as normal, strong electrolytes at low concentration, but at higher concentration, they behave as colloidal solutions due to the formation of aggregated particles known as micelles. For example, soaps and detergents. Mechanism of micelle formation. The formation of micelles takes place only above a particular concentration, called critical micelle concentration, and above a particular temperature called Kraft temperature. Micelles are formed by surfactant molecules. These molecules have lyophilic as well as lyophobic ends. For example, sodium stearate. When soap solution is dilute and the concentration is below its CMC, sodium stearate behaves as a normal strong electrolyte. When the concentration exceeds cmc, the non-polar tails of the anion clump into the center of a ball-like structure called a missile, because these are hydrophobic. The polar head of the molecule presents itself for interaction with the water molecules on the outside of the missile. This type of missile is known as normal phase missile. Inverse missiles have the head group at the center with the tails extending out. These are formed in non-polar media. Preparation of colloids by chemical methods. Colloidal solutions can be prepared by chemical reactions involving double decomposition, oxidation, reduction, and hydrolysis. Double decomposition. A colloidal sol of arsenious sulfide is obtained by passing hydrogen sulfide into a solution of arsenious oxide in distilled water. Oxidation. A colloidal solution of sulfur can be obtained by passing hydrogen sulfide into a solution of sulfur dioxide in water or through a solution of an oxidizing agent. Reduction. A colloidal solution of a metal can be prepared by reducing its salt solution with a suitable reducing agent. Hydrolysis. This method is used to prepare hydroxides and oxides of weakly electropositive metals. A red sol of ferric hydroxide is obtained by the hydrolysis of ferric chloride with boiling water. Preparation of colloids by electrical disintegration. This process is also known as Bredig's arc method. It involves dispersion as well as condensation. Colloidal solutions of metals can be prepared by this method. In this method, electric arc is struck between electrodes of the metal immersed in the dispersion medium. The intense heat produced vaporizes some of the metal, which then condenses to form particles of colloidal size. Preparation of colloids by peptization. Peptization is the process of converting a precipitate into colloidal form by shaking it with dispersion medium in the presence of small amount of electrolyte. The electrolyte used for this purpose is called peptizing agent. During peptization, the precipitate adsorbs one of the ions of the electrolyte on its surface. The adsorbed ion is generally common with those of the precipitate. This causes the development of positive or negative charge on precipitates, which ultimately break up into smaller particles having the dimensions of colloids. Purification of colloidal solutions. The process used for reducing the amount of impurities to a requisite minimum is known as purification of colloidal solution. The purification of colloidal solution can be done by following methods. Dialysis. It is a process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable membrane. The apparatus used for this purpose is called dialyzer. Electrodialysis. The process of dialysis is quite slow. It can be made faster by applying an electric field if the dissolved substance in the impure colloidal solution is only an electrolyte. Then the process is known as electrodialysis. Ultrafiltration. In this method, colloidal solutions are purified by carrying out filtration through special type of graded filters called ultrafilters. These filter papers allow the electrolytes to pass through them but do not allow colloidal particles. Properties of colloidal solutions. Colligative properties. Due to high average molecular masses of colloidal particles, they give very low mole fractions in colloidal solutions. Hence, they possess very low values of colligative properties. Filtrability. The size of the colloidal particles is less than the pores of the filter paper, and therefore, they easily pass through a filter paper. They cannot pass through the UF membrane. Tyndall effect. When a strong beam of light is passed through a true solution, it cannot be seen unless the eye is placed in the path. However, when the same beam of light is passed through a sol, the path of light becomes visible with a bluish light. This phenomenon is called Tyndall effect. This phenomenon is due to scattering of light from the surface of colloidal particles. Colloidal particles are too small to be seen with naked eye. They scatter light and become visible as bright spots or disks of light against a black background when viewed through an ultramicroscope. Brownian movement. When colloidal sols were observed under a microscope, scattered light was seen moving in a zigzag motion. As the light is scattered by colloidal particles, these particles execute ceaseless, erratic random motion called Brownian movement. It is due to the bombardment of colloidal particles by the molecules of the dispersion medium. Due to Brownian movement, the colloidal particles do not settle down under the force of gravity, and therefore, it is an important factor for the stability of the sol. Electrophoresis. The particles of the colloidal solution are electrically charged. The existence of the electric charge is shown by the phenomenon of electrophoresis. It involves the movement of colloidal particles either towards the cathode or anode under the influence of electrical field. The colloidal solution is placed in a U-tube fitted with platinum electrodes. On passing an electric current, the charged colloidal particles move towards the oppositely charged electrode. Coagulation of colloidal solution. The precipitation of a colloid through induced aggregation by the addition of some suitable electrolyte is called coagulation. The coagulation of a colloidal solution by an electrolyte does not take place until the added electrolyte has certain minimum concentration in the solution. The minimum concentration of the electrolyte in millimoles that must be added to 1 liter of the sol so as to bring about complete coagulation is called the coagulation value of the electrolyte for the sol. Different electrolytes have different coagulation values. Smaller the coagulation value of the electrolyte, larger is its coagulating power. Emulsions. An emulsion is a colloidal dispersion in which both dispersed phase and the dispersion medium are liquid. In an emulsion, fine droplets of one liquid are dispersed in a continuous medium of another liquid. Emulsions are of two types: oil in water and water in oil. Oil in water. In these emulsions, some droplets of oil are dispersed in water. For example, milk is oil in water type of emulsion, in which liquid fat is the dispersed phase and water is the dispersion medium. Water in oil. In these emulsions, water is the dispersed phase and oil is the dispersion medium. Stiff greases are emulsions of water in oil type, in which water is dispersed in lubricating oil. Colloids around us. Colloids play very significant role in nature and our daily lives. Some important examples are as follows. Blue color of the sky. It is due to scattering of light by colloidally dispersed dust particles in air that sky looks blue. Fog and mist. They are colloidal systems. When large mass of air containing dust particles cools below its dew point, the moisture present in the air condenses on the dust particles, forming fine droplets. Food items. Most of the food items are colloidal in nature. Blood. It is a colloidal solution of an albuminoid substance. Soils. Fertile soils are colloidal system, and on account of their colloidal nature, soils absorb moisture and nourishing materials for plants. Paints. All paints are colloidal dispersions of solid pigments in a liquid medium. Medicines. Many medicines are colloidal in nature. The medicines in colloidal form are easily absorbed by body tissues and are more effective. Digestion of fats. The digestion of fats is aided by emulsification. Applications of colloids. Due to the presence of electrical charge on colloidal particles, they are good conductors. Some important applications of colloids are rubber plating. The negatively charged rubber particles from the rubber sole are deposited on wares and handles of different tools by electroplating. Sewage disposal. Sewage water contains particles of dirt, rubbish, etc., which are of colloidal size, carry charge, and therefore do not settle down easily. These particles can be removed by electrophoresis. Cottrell smoke precipitator. Smoke is made free of colloidal particles by passing it through Cottrell precipitator installed in the chimney of an industrial plant. Formation of delta. When river water comes in contact with seawater, coagulation of colloidal particles occurs. These coagulated clay particles settle down at the point of contact and gradually river bed starts rising. Artificial rain. It is caused by spraying oppositely charged colloidal dust or sand particles over the clouds. The colloidal water particles of the clouds get neutralized and coagulate to bigger water drops which cause artificial rain. Purification of water. The colloidal particles present in water can be precipitated by addition of small amount of alum. The Al+3 ions furnished by alum help in coagulation of impurities which are present in the colloidal form. Did you know? Bone black and charcoal are used in industry to remove colors from solutions since they absorb many coloring materials. Sometimes, the smoke emitted by motorcycles seems to be blue in color, is an example of Tyndall effect. The enzyme tyalin, found in human saliva, accelerates the reaction so that starches can be digested. The clotting of blood is an example of coagulation. Summary. Let us summarize what we have learnt. Surface chemistry is that branch of physical chemistry which deals with the study of the phenomena occurring at the interface. The phenomenon of attracting and retaining the molecules of a substance on the surface, leading to a higher concentration on the surface in comparison to the bulk, is called adsorption. A catalyst is a substance which influences the speed of a chemical reaction without itself undergoing any chemical change at the end of the reaction. The enzymes are highly specific in their action. The specificity of an enzyme is due to presence of some specific sites called active sites. A colloid is a heterogeneous system in which one substance is dispersed as very fine particles in a continuous medium of another substance. Peptidization is the process of converting a precipitate into colloidal form by shaking it with dispersion medium in the presence of small amount of electrolyte. The precipitation of a colloid through induced aggregation by the addition of some suitable electrolyte is called coagulation. An emulsion is a colloidal dispersion in which both dispersed phase and the dispersion medium are liquid.